So this is First Eye on the Sky, a rough guide if you were interested in buying yourself a telescope because you're interested in astronomy, if I've piqued your interest in particular, what's the sort of thing you need to think about before handing over your cash to somebody and buying yourself some astronomical gear. So I'll be talking about buying your first telescope. I'll be saying a little bit about how telescopes differ from each other, how we actually make sure that telescopes are capable of tracking the sky. Remember, the Earth's rotating, therefore the sky appears to move, so we need to somehow mount the telescope to follow the stars in the sky, and there are different ways of doing that. I'll be asking about pros and cons, or at least giving you a little bit of indication of why you might want to choose one telescope over another, and I'll give you a rough guide to prices. Finally, I'll just say a few hints and tips as to things you ought to watch out for if you are thinking of buying a telescope. So the common question is, my grandson is interested in astronomy. I want to encourage him. Which telescope should I buy? Well, unfortunately, there are some real toys out there which aren't necessarily worth buying. And there are some that look very gimmicky and you think, well, does that actually work as a telescope? So there are guides out there, and again, I can send links to Laura to pass on to you as to where you can find useful information that give you a guide to how you find out about what sort of things I ought to be thinking about. Beginner's guides, there are lots of them available on the web. It's perhaps not clear which ones are reliable and which ones are. Bear in mind that if you look at a guide to how to buy a telescope, if it's sponsored by a particular manufacturer of telescope, they will of course be giving you examples which are their own telescopes. They won't necessarily be telling you about other telescopes that are out there. So bear in mind that if they are sponsored, then you just have to take that with a pinch of salt. And this is just taking one of those guides and giving you an idea. Lots of useful information, not written in any sort of technical way. It's very useful. Watch out for this, bear in mind that, etc. Useful information about how telescopes work, how they're mounted, and what accessories you might want to buy. And in some cases, even advice like don't buy a telescope, buy binoculars instead. That might be better, especially to start with. But if people start saying, well, okay, I think I am interested, I definitely want to spend a few £100s on a telescope, which one is for me? Well, you can get brochures from manufacturers that tell you about particular telescopes. But the problem is not a lack of information. On the contrary, the problem is a huge amount of information about different telescopes that are available. For instance, here is 6 pages from this particular brochure telling you about different telescopes, and there are, what, a dozen or more telescopes there. That's the first 6 pages, and then we've got a few more, and 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 now we've got a few accessories and other things as well. So it's no surprise that if anybody starts to say, well, which is the best telescope, you're bombarded with thousands of possibilities. Even if you limit yourself to 1 or 2 or 3 or 4 different manufacturers, you still have thousands of telescopes, different sizes, different functionality, as well as humongous numbers of accessories. If you wanted to, you can throw money at astronomy and you can sink a small mortgage into buying astronomical gear, including if you're interested in astrophotography. Just to give you a quick guide, the sort of classic idea of a telescope on the left-hand side there uses lenses to collect the light, and some of the larger telescopes also use glass to collect light. On the right-hand side, using mirrors instead. Generally speaking, it's easier to make a large mirror than it is to make a large lens, so there are telescopes that are designed using mirrors, and the ones in the middle there actually use both. They use glass and they use mirrors in a combination which makes them a little bit cheaper to manufacture. They're called, don't worry about the names, they're called technically dioptric or catadioptric telescopes, but everybody tends to refer to them as the ones that use glass are called refractors, the ones that use mirrors are called reflectors because they're reflecting off the mirror, and the ones that have a combination of using glass and mirrors are called cats because of their original catadioptric name. But that's the easiest way of referring to different telescopes. Are they refractors or are they reflectors? So let's just have a quick look at a refractor. A lens at the front end of the telescope collects the light, and then it focuses it down to the bottom end there where an eyepiece is used to have a look at the image. So the light comes through the objective lens, is focused to a point, and then an eyepiece is used to actually look at the light. Generally speaking, although in principle you just need one lens to focus light, in practice very few telescopes actually just have a single lens at the front, because light going through a prism tends to produce a spectrum of light. The same is true with a single lens, so quite often they have doublets or triplets, in other words, different lens elements to try and keep colour correction under control, so you don't end up with something that looks like the front cover of the Dark Side of the Moon album. You don't end up with a rainbow of colours produced by the lens. That makes it more expensive, but you get better images if you do that. Cheaper than making lenses is to use mirrors. So for instance, if we have a mirror with a particular shape called a parabola, a parabolic mirror, you can take light and it will come to a nice focus. But of course, if you stick your head close to the focus, you'll block the incoming light. So you've got to do something about taking that light somewhere else. So one option is to put a 45-degree mirror in there, send the light off sideways, and that's where your eyepiece is. That's why you see some telescopes with an eyepiece not at the bottom end but at the top end on the side, a so-called Newtonian design, because it was originally proposed by Isaac Newton, who built one of the smallest Newtonian telescopes. So a flat mirror is the easiest thing to put the telescope on one side. Cassegrain is a different type of design in which again the light is focused by a main mirror, but instead of putting your head there, or instead of coming out to the side, a curved mirror is placed there, and that sends the light back down through the main mirror. The disadvantage, you have to have a hole in your main mirror, but that's actually not difficult to manufacture. So that particular design, a so-called Cassegrain design, that's used by, for instance, the Hubble Space Telescope, so it can't be bad if they use it. An alternative is to make that mirror as cheap as possible by making it slightly the wrong shape, because that's cheaper than making it the correct shape. But by making it the wrong shape, you need to have some sort of correction in, and you can correct it using a piece of glass at the front. So that's this so-called catadioptric design, or technically it's called a Schmidt-Cassegrain. It has a piece of glass at the front and a mirror at the back. And because it's got glass at the front and mirror at the back, that's why these things are called cats, because they have elements of glass and elements of reflection. And in some smaller telescopes, that front piece of glass is actually curved, and so you notice that some telescopes actually have a dish-shaped front element, because the so-called corrector plate that corrects for the fact that the mirror has been made rather cheaply is slightly indented, and so that's a characteristic of those types of telescopes. So even if you say, okay, I can see that those are lenses, those are mirrors, and we can have this design or that design, it's still very complicated, and you still end up with a price list which goes from hundreds of pounds to, well, many, many thousands of pounds. You have to decide not only what type of telescope you want, but how are you going to mount that? Remember, we want to be able to point the telescope into the different parts of the sky, and ideally we would like it to move in the way that the stars move. The simplest telescope mounts, like the one on the left-hand side, one of the cheapest ways of getting the telescope to move, is simply to allow it to move in altitude and to allow it to move in azimuth, a so-called alt-az design. But you can spend more by making it either motorized. So in this case, this is a telescope which is on a single arm, and there are motors inside the arm and inside the base that allow you to control where the telescope is pointing, not by picking it up and dragging it, but by just having a little keypad of some kind and buzzing it to the left and then up until you see the object that you're interested in. Generally speaking, the more complex the mount, the more expensive. The more things it can do, the more expensive it gets. So it's not just a question of choosing the largest telescope you can afford to collect as much light as possible. You have to think to some extent as, how am I actually going to use this telescope? Some mounts are at a rather jaunty angle. You might say to yourself, well, I can see the idea of going up and down and going left and right. I can point to any part of the sky. Why would you want to choose a mount which has axes at rather jaunty angles? Well, that's just based on the fact that that's the way the Earth spins. The Earth spins, and of course the North Pole, which points to the North Celestial Pole, is a particular point in the sky, but we don't live at the North Pole. We live at a particular point, 52 degrees latitude or thereabouts, 52, 53 degrees. And so the Earth spins about an axis which is not simply vertical as far as I'm concerned sitting in England. And so we might be interested in moving the telescope about an axis which is parallel with the Earth's axis, because that paradoxically makes it easier to follow the stars. So it might seem that these jaunty angles are unnecessary, but if we set up one of these mounts, simply called an equatorial mount, because it's aligned with the Earth's pole and the Earth's equator, it means that we only need to move in one axis in order to take into account the fact that the Earth is rotating. The Earth is rotating about an axis which is not vertical. If I set my telescope up the right way, then it will automatically follow the stars correctly. So that's why we might want to buy ourselves an equatorial mount rather than simply an alt-az mount. And a lot of people who say, I'm interested in astronomy, or I want to buy a telescope, or I'm interested in looking at the stars or whatever, often ask about, well, how can I take some of these wonderful photographs that I see in magazines? And that, you could argue, is a different kettle of fish. Buying a telescope that allows you to see distant objects, whether they be the planets or stars or nebulae or whatever, that's one thing. But buying the equipment you need to take wonderful images, well, that can get rather more expensive. So yes, you can buy small cameras that effectively replace the eyepiece. Instead of looking through the telescope and saying, I can see Saturn, you replace the eyepiece with a small camera, and that allows you to get rather nice images of the moon or nice images of planets, which are relatively bright compared to some of the objects in the universe. But so-called deep sky objects, deep sky means not simply things in our solar system, but more distant objects like nebulae somewhere in our galaxy or galaxies far, far away. So they take a little bit more effort, and you will need to take relatively long exposures, and long exposures of many, many seconds or minutes, or in some cases hours, if they're really faint objects. If you want to take long exposures, you've got to make sure your telescope tracks the sky and follows. Otherwise, you're trying to take a picture of this galaxy, but 5 minutes later, your galaxy's over there and your telescope's pointing in the wrong direction. So in other words, your beautiful image will blur unless your telescope follows, or so-called tracks, the sky accurately. So serious astrophotographers, in other words, the sort of people that generate images that you tend to see in glossy magazines or occasionally on YouTube videos, they might decide to buy themselves a dedicated camera. Personally, I'm of the ilk that I prefer to use the camera I've already got. If I am interested in photographing things in daylight with my camera, whether they be the cat in the back garden or the family or my holiday snaps, I would prefer to use the same camera for astrophotography. And yes, they do work. Cameras that are designed to take pictures in daylight can be used to take very nice images of the night sky. So although some people say, I want to buy a telescope because I want to take pictures of the night sky and I want to take pictures of a galaxy or a nebula or whatever, I often remind people, well, if you've already got a camera, you can take pictures like this. These images on the right-hand side were all taken by me with that camera. A Nikon camera, it's shown there without a lens because some of these are taken with a wide-angle lens, some of them are taken with a telephoto lens. But yes, you can take a picture of distant nebulae, you can take a picture of a star that's blown itself apart in a supernova, you can take a picture of, for instance, the Andromeda Galaxy. You can take pictures like this without a telescope. You simply need to make sure that your camera moves in such a way that it tracks the sky. And these objects are called, these things are called star trackers. They are basically just a box with a motor in it that allows the camera to move such that you can take images without them blurring. So remember, you do not need a telescope. Yes, astrophotography with a telescope can produce some incredible images by amateurs from their back garden. But beware, it will take time. It will take a certain amount of effort. And it will take a shed load of cash to get all of the equipment you need to buy a very big telescope and the relevant mount and to get some of the images that you might be interested in. So if you are interested in photographing nebulae or galaxies or planets, whatever, bear in mind that you don't have to start with a telescope. You can start with something altogether cheaper. And a tracker that can be used to move a camera to follow the sky. I built one for about 20 quid. You can buy commercial star trackers, but you don't have to buy commercial star trackers. You can build one yourself for about 20 quid and take images like that if you've already got a camera. So let me make a few points about pros and cons of either a telescope using lenses, a refractor, or one using mirrors like a Newtonian or a Dobsonian. A Dobsonian is just a similar version of a Newtonian, it's just on a cheaper Altaz mount. And then we have Maksutov, the catadioptric telescope with a curved front element, and a slightly larger version, a so-called Schmidt-Cassegrain, which is a catadioptric with a flat front element. So what are the pros and cons of these 5 different types of telescope? Well, if you are interested in using a small refractor, that's fine, but bear in mind lenses produce colors because they act like prisms effectively. And so you can get the color fringing under control, but generally speaking, you have to pay more for a good quality lens to make sure they don't produce color fringing. Alternatively, you use mirrors, which don't have the problem of producing colored rainbows whenever you get a reflection, and that's why Newtonians are often considered one of the favorites for amateur astronomy. A small, relatively modest-sized mirror can produce some nice images, and you don't worry about color fringing, and that's the same for the Dobsonian as well. Dobsonian is just a Newtonian telescope on the cheapest mount that you can get away with effectively. One of the advantages of the catadioptric is because you're reflecting from the main mirror and then off a secondary mirror, you get a relatively long focal length in a relatively compact object. In other words, you get a relatively large telescope, but it's only that big. It's like having a big telescope folded up into a smaller object. And so that's an advantage if you're interested in moving these telescopes around. If you're interested in the faintest of objects, not necessarily the moon or the planets, but faint objects like galaxies, you want the largest mirror that your pockets will allow. Basically, the large mirror means collecting more light so you can see faint objects. So for deep sky objects like galaxies, you would go for a Newtonian or perhaps a Dobsonian or a Schmidt-Cassegrain, which is a large aperture. Refractors tend to be smaller apertures. Maksutovs tend to be smaller apertures. Large aperture for a given price, the Dobsonian is effectively a Newtonian on a very simple Altaz mount, and therefore some people regard those as the best value for money if you're interested in eyeballing. Not necessarily for photography, but if you're interested in eyeballing objects, that's one of the best value for money. And again, we're getting a little bit technical, but these particular types of telescopes are sealed in the sense they're not open. This has a mirror at one end and it's an open tube, which means that spiders can get in and you've got to watch what's going on. With these telescopes, they're sealed at both ends, so there's, generally speaking, the optics don't need to be adjusted and you don't get any small critters getting into your telescope when you're not watching. For some people, what's absolutely important is not necessarily the technical specification of the telescope. Is it small enough that I can actually get it out of the house into the back garden, or out of the back garden into the back of the car and then drive to a nice dark site? So portability or transportability is sometimes an overriding factor for some people. I'm not going to dwell too much on this. Again, there's a copy of it in the handout if people are interested, but I tried to give people a guide to what you might have to pay if you want a telescope of a given size. In other words, if you're interested in a refractor, you perhaps can't read all of the detail, but a refractor with a lens that's 3 inches in diameter might cost you £100 or so. A refractor with a lens that's 5 inches in diameter will be substantially more expensive, perhaps £500 or so. whereas the amount you would have to pay for a similar size of different types of telescope will depend very much on the type of telescope. Some are cheap to build, some are expensive to build, and therefore the price you pay will depend on which telescope you are interested in. This is simply a guide so that if you look in a magazine and say, or if you see an advert on Facebook, these people are selling a 6-inch Newtonian telescope and they seem to be selling it for £2,000. Newtonian telescope, 6-inch, well, it ought to be £400. It looks like they're ripping me off. This is just a way of getting a guide to what sort of prices that you might have to pay. If you've only got a few tens of pounds, I would argue get a good pair of binoculars. Don't think about buying a really cheap telescope. Some people would argue, well, that's a fantastic telescope to start with. A 5-inch mirror in a Newtonian will be really good. Other people say, no, you really ought to go for a Dobsonian because you get a larger telescope for your money. Well, I would argue pretty much any telescope in that blue rectangle is probably going to be decent enough if you don't buy it from a cowboy. Some people, like Sky at Night magazine, say you really ought to start with an 8-inch telescope, but who's got £700 they can just throw around? Unless you absolutely know this is the hobby for you, most people would rather start at perhaps a few hundred rather than the top end of this scale. And if you're interested in doing some astrophotography, as I've indicated, you can build yourself a star tracker and take pictures of galaxies and take pictures of nebulae and take pictures of supernova remnants. You can start from literally a few tens of pounds. And I can send you the instructions as to how you build yourself a star tracker if you're interested. If you wanted to, you could you can buy clockwork versions of a tracker or motorized versions of a tracker. But if you want a very complex mount that will allow you to do astrophotography with a big telescope, that's when it starts to get expensive, because motor-driven mounts can be expensive, and go-to mounts, the sort where you can basically have a hand controller in which you can say, I'm interested in taking a picture of this galaxy, and then the mount knows where it's pointing, the mount knows where the galaxy is because there's a small computer on board, and it will point at that galaxy for you. That takes all the fun out of it, rather than trying to figure out where do I need to point the telescope to find the galaxy. But some people like the idea of go-to, but go-to starts to get very expensive. So that's before you've even thought about how expensive is the telescope that I'm going to put onto this go-to mount. So there we start talking about, well, it could easily be thousands by the time you've finished. I would argue that you can't go far wrong if you stick to the big 5 manufacturers available in the UK. This one has now ceased trading, so you could argue that this is now the top 4 manufacturers in the UK. If you get one of those telescopes, you will probably not get a turkey. If you go for something else, there's always the possibility it won't be up to the quality produced by these manufacturers. What matters? Is it the focal length? Is it the length of the telescope, or is it the aperture of the telescope that really matters when you're considering the various types that are available? Of the two, it's the aperture that really matters. The aperture determines how much light is collected, and that determines how faint an object you can see and how clearly you can see an object. The focal length, the length of the telescope, effectively determines the magnification. Now, that might be important if you're looking at really tiny objects like planets at a great distance, but magnification is probably less important than you think. You can replace eyepieces, and you can get low magnification eyepieces and high magnification eyepieces. So you can always buy yourself a telescope and then decide later which particular eyepiece. There might be 1 or 2 eyepieces come with the telescope, but after you've bought the telescope, you can decide, I'm not happy with that magnification, I would like a different magnification, and you can buy yourself another eyepiece. But on the whole, magnification is possibly less important than you think. It doesn't matter if you haven't got times 1000 on your telescope. What matters is, can I see detail? It doesn't matter whether it's small or big. If something is blurry, making it big and blurry doesn't help. So you may as well just stick to something small. Remember about the ergonomics? You might decide to go for a small telescope simply because it's something you can lift and take outside onto the patio table or easily put into the back of a car. So you have to ask yourself, how am I going to use this telescope? And remember, astrophotography is a horse of a different colour. The specification you need for a telescope that gives you wonderful views of the universe is not necessarily the same for the telescope that gives you the best photos of the universe. So it's a good idea to know up front, are you doing this because you want to see stuff, or are you doing this because you want to photograph stuff? Making that choice early is a good idea. And as for go-to telescopes, yes, some people think it's the best thing ever invented, the fact that you can, without knowing where things are in the sky, you can punch them into a little handset and the telescope will go away and point in the right direction. For some smart telescopes, it'll not only go and find the galaxy for you, it'll take a picture of it for you. I'm thinking, well, why? You can just download images from the Hubble Space Telescope. Why would you want it to do all the work for you? It turns you into a backseat driver. Some people say they're the spawn of the devil. Some people say this is a great idea because I don't have to learn my way around the sky. Well, why are you doing astronomy if you're not interested in learning the sky? Do you really just want the universe in your lap, or do you want to find out where things are? Do you want to learn the difference between looking at this nebula and looking at that galaxy? As always, try before you buy. It's great if you can latch on to a local astronomical society and borrow or use their gear. In other words, go to a star party and look through various telescopes and say, he's got that telescope, he's got that telescope. I look through that one, I'm not impressed with that, but I do like the idea of that one. You can get an idea effectively from borrowing other people's equipment. If you do see a bargain second-hand, make sure it is a bargain. Ask an expert. This person is selling this on Facebook and they're saying it's 2,000 quid's worth of telescope and they're selling it for 100 quid. Is that a bargain? Take an expert's opinion before you part with your cash. It's always tempting to buy a telescope and then say, there's an accessory that comes with it. I can buy that telescope, but for an extra 100 quid, I could also buy this. And for an extra 100 quid, I could also buy that. And for an extra 200 quid, I could also buy this. And it's tempting to just keep adding to your telescope until you end up with something which is technically wonderful, but almost impossible to use. And some people seem to buy enough accessories before they run out of cables to actually bolt them all together. So again, ask yourself, why are you doing this? Are you doing this because you're a techie and you just love buying gadgets? Or are you doing this because you want to buy a telescope and see the universe for yourself? It can be misleading sometimes, not necessarily in this particular brochure, but I have seen adverts and other things, whether they are magazines or brochures or sometimes adverts in various publications, where you see this telescope is more expensive than that telescope, and you're thinking, okay, well, that one's cheaper than that one on the right, so maybe the one on the left is better value for money. But bear in mind, not everybody shows these images to scale, because if you show them to scale, you realize they are extremely difficult, the different telescopes. So that's why the one on the left is cheaper than the one on the right. You have to ask yourself, how are you going to use it? Which is a comfortable height for you? Do you really want something that's that big so you can get a nice comfortable position on the eyepiece? Are you happy to use a telescope from a seated position? Maybe that's better for you. And maybe you want a telescope that's small enough that you can just plonk it on the patio table and then point at various objects. So you have to ask what it is you're doing. And remember, although generally speaking, large apertures are good, big apertures, big mirrors means collect more light, fainter objects, more detail. It's a win-win situation, except that bigger telescopes are heavier. And maybe you're quite happy with the idea of lifting a 2-kilogram telescope out of your kitchen and into your back garden. Maybe you're not too fussed about the idea of picking up something that weighs 24 kilograms. Again, can your car take something that large? If you want to put it in the back of your car and drive to a really dark site beyond the edges of Manchester, for instance. So make sure you do read the specification with an expert if necessary to tell you what that specification actually means. Make sure you know what it is you're buying before you part with your cash, because you might end up with something that is absolutely superb, but you didn't realize quite how big it was. And in this particular case, 300 kilograms, this particular telescope. So a beautiful telescope. Yes, it's a real one, and that is indeed its actual size and its actual mass. But Meade and other companies will take into account the fact that, that these telescopes are really, really weighty. And they'll make sure that that's compensated by the fact that your bank balance will be a lot lighter by the time you've actually bought something like that. And yes, you do need a second mortgage for a telescope like that. So the bottom line is your options are many and varied. If you're interested in buying a telescope, you could literally buy any one of hundreds, if not thousands of different types by the time you've taken into account the different models from the different manufacturers with the different size mirrors and the different focal lengths and the different accessories, etc. Yes, your options are many and varied, which is fantastic in terms of availability, but also very bad in terms of, well, it's really confusing to figure out why is that one any better than that one? Why is that one twice the price of that one? Am I actually getting any better use out of it if I were to go with this rather than that? Or am I going to buy this telescope and then find it's actually not the telescope I wanted, so I've just spent hundreds of pounds on something I really can't use very effectively? But the advice is don't suffer from analysis paralysis. In other words, you could go round forever. You could spend years doing the research as to which telescope is really the best telescope. And by the time you've decided that, somebody has come out with a different telescope. So look at what you can afford. Basically, of course, it has to be within your budget. Take advice, ideally from somebody in an astronomical society who can say, these telescopes are really good. Most people have found these are really useful. Those are great, but they're really expensive. So look at these rather than those. Ultimately, take some advice, make a decision, and then enjoy your stargazing rather than spend months and months and months and months deciding what you want to do and then finding, okay, my eyesights have now depreciated somewhat, so get in there whilst you can. If you want to do some stargazing, take advice, buy a telescope, and then enjoy your stargazing. Make full uses of whatever resources are available to you, whether it be a library or whether it be an astronomical society. And ultimately, remember that people are the best way of getting advice. Yes, I know YouTube has got lots of videos telling you this is what I suggest you buy, but the best thing is to have a face-to-face conversation with somebody who knows what they're talking about. What is the best telescope to use? Well, the best telescope for you is the one you actually use. Thank you.